This is a video on augmented matrices. Let's just jump straight into an example, why don't we? Solve the system using Gaussian elimination. X plus y minus 2z equals 7. Negative x plus 4y plus 3z equals 2. 2x minus 3y plus 2z equals negative 2. Hey, that looks like a problem I already know how to solve. What are you doing here, Mr. Shaver? Well, we know how to solve a system of equations, and we've done ones that have 3 variables with 3 equations. What we're doing in this video is learning another method for solving a system like that, a method that involves a matrix. So the first thing we need to do is turn this system of equations into a matrix. The system has 3 equations, so my matrix is going to have 3 rows. And the way I form the matrix is just use the coefficients of the variables, so not the variables themselves, but the numbers in front of them. So there's 1x in my first equation, so my first row starts with a 1, and then 1y, so it's a 1, negative 2, and then a 7. My second equation is negative 1, 4, 3, and 2. And then the last row comes from the third equation, 2, negative 3, 2, negative 2. And I draw a dotted line separating the last column from the rest of them. That dotted line represents the equal signs in my 3 equations. So I have this matrix. This is called an augmented matrix because it's not square. It has 3 rows and 4 columns. It's a rectangle that's not a square, so it's an augmented matrix. Our process for solving this system is called Gaussian elimination. The goal of Gaussian elimination is to put the matrix in what's called a row echelon form. This is what I mean by row echelon form. A 1 in the top corner, zeros all below it, a 1 along the diagonal, and a 0 below it, and then another 1 along that diagonal, and then you have your dotted line, and then you have other numbers. There's another number, another number, another number to complete the first row, another number, and another number to complete the second row, and then another number to complete the third row. So what you're seeking in Gaussian elimination is this triangle of 1s and 0s. 1s along the diagonal starting in the top left corner, and 0s all below that diagonal of 1s. And then all the other spots are just any number. It could be 0, could be 1, could be any other number. Alright, so how do we get that? Well, our first objective is accomplished. We have a 1 in the top left corner just because our equation happened to start with a 1 there. If it didn't, if it was anything else, a valid move I can make is to divide an entire row by a number, just like I'm dividing an entire equation by the same number. I can do that with a row of my matrix because my rows are just representing equations. So everything I could do with equations, I can do with the rows. So if it was a 2 in the top left corner, I could divide the whole row by 2, and then all of a sudden I'd have a 1 in that top left corner. But I've got the 1. So now I'm going to start by getting the 0 that's right underneath the 1. The way we do that is to add 2 rows together and replace a row with what we get when we add 2 rows together. So I'm going to add the top row and the second row and replace the second row with what I get there. So if I call the top row row 1 and then row 2 and then row 3, what I'm going to do is take row 1 plus row 2 and use it to replace row 2. So when I add the 1 and the negative 1, I get 0. The top row doesn't change though, so I'm just going to copy the top row over. The second row becomes my new row of when I add the first row and the second row together. So the 1 and negative 1 makes 0. The 1 and the 4 makes 5. The negative 2 and 3 is 1. 7 and 2 is 9. So notice I've got the 0 right underneath my 1 now. Pretty easy to get that. Now I keep going down that first column, and I want the 0 in that bottom left corner. So I want to add 2 rows together in a way that cancels out the 2 that I have in that bottom left corner. Well, one thing I can do is multiply a whole row by a number. So if I were to multiply the top row by negative 2 and add that to the bottom row, I'll get a 0 on that bottom left corner. So we're doing negative 2 times the first row plus the third row to replace the third row. So negative 2 times 1 is negative 2, plus the 2 makes 0. Negative 2 times 1 is negative 2, plus the negative 3 makes negative 5. Negative 2 times negative 2 is positive 4, plus the 2 makes 6. Negative 2 times 7 is negative 14, plus the negative 2 is negative 16. So now I've achieved the whole first column. I've gotten it to be a 1 in the top left corner and zeros below it. Now I move on to the second column. I don't care what the top number is in the second column. It can be whatever it wants to be. Here it's a 1, that's fine. I want the number right below that to be a 1. It's a 5. How do I get a 5 to be a 1? Well, I divide it by 5. So that's what we're going to do. I'll continue this up here. We're going to just divide row 2 by 5. So row 1 doesn't change. But row 2 gets divided by 5. So 0 divided by 5 is 0. 5 divided by 5 is 1. 1 divided by 5 is 1/5. And 9 divided by 5 is 9/5. Okay, the bottom row stays the same. 0, negative 5, 6, negative 16. But now I want that negative 5 to be a 0 as I keep working down to the right of my triangle. I want that negative 5 to be a 0. How do I get it to be a 0? By adding 5 to it. How do I get a 5? I'll multiply the second row by 5. So 5 times this new row 2 here plus the third row is going to replace the third row. So the top row doesn't change, and it won't change from here on. Second row doesn't change, and it won't change from here on. I'm now just working in the bottom row. I take 5 times the second row, add it to the bottom row. So 5 times 0 is 0 plus 0 is 0. 5 times 1 is 5 plus the negative 5 is 0. 5 times 1/5 is 1 plus the 6 makes 7. 5 times 9/5 is 9 plus the negative 6 makes negative 7. Okay, I'm almost finished with my triangle. I've got one more corner to fix. That 7 right there needs to become a 1. How do I make a 7 into a 1? I'll just divide it by 7, of course. So we're going to divide row 3 by 7. I'm just writing those instructions for you so it makes sense to you what I did. So the top row doesn't change. Second row doesn't change. Bottom row changes by dividing it by 7. So 0 divided by 7 is 0. 0 divided by 7 is still 0. 7 divided by 7 is 1. Negative 7 divided by 7 is negative 1. Hey, we got our triangle of 1s and 0s. Perfect. Now, you might ask, well, what does that do? Well, we now remember that these things really represent coefficients of the variables. So in that bottom row, what that's telling me is 0x plus 0y plus 1z equals negative 1. Or in other words, what the bottom row says is z equals negative 1. Hey, I found one of my 3 variables. How do I get the other ones? Well, I work up in my matrix. The second row, it says that 1y plus 1/5 z equals 9/5. But I know z is negative 1. So y plus 1/5 times negative 1 equals 9/5. So y equals 9/5 plus the 1/5, when I add that to the other side, makes 10/5, which is 2. Almost done. I just need to find x. So I go back to the top row now. that top row says that x plus y minus 2z equals 7. Well, I know y is 2. Z is negative 1, so that makes it a plus 2 equals 7. So x plus 4 equals 7, and x equals 3. What's my solution? Well, the solution set is the point, the ordered triple, x comma y comma z, 3 comma 2 comma negative 1. Pretty cool, right? Right? Good. Number 2. Solve the system using Gaussian elimination. You can really impress your friends and your parents and your relatives and your girlfriend by telling them that you now know how to solve a system of 3 equations using an augmented matrix using Gaussian elimination by getting into row echelon form. They'll be really impressed. So you set up the matrix. That should be an X there. We got 2, negative 1, 3, 5, 4, 1, 0. There's no z's in that second equation. 13, 3, 0. There's no y's in that third equation. Then a 4 and a 4. First objective, get a 1 in the top left corner. I don't have a 1 there. I've got a 2. So I divide that by 2. That gives me 1, negative 1/2, 3 over 2, and 5 over 2. Now I've got a 1. Next objective, 0 underneath the 1. Well, right now it's a 4. How do I get the 4 to be a 0? I add a negative 4 to it. How do I get a negative 4? I multiply the top row that has a 1 there by a negative 4 and add it to the second row. So you're doing negative 4 times the first row plus the second row to replace the second row. So negative 4 times 1 is negative 4 plus the 4, 0. Negative 4 times negative 1/2, positive 2, plus the 1 is 3. Negative 4 times 3/2 is negative 6, plus the 0, negative 6. Negative 4 times 5/2 is negative 10, plus the 13 is 3. All right, I want that last number in the bottom left corner to also be a 0. Right now it's a 3. How do I get it to be a 0? I add negative 3 to it. How do I get a negative 3? I multiply the top row by negative 3. So negative 3 times row 1 plus row 3 is going to replace row 3. So negative 3 times the 1 makes negative 3 plus the 3 makes 0. Negative 3 times negative 1/2 is positive 3/2 plus the 0 that's down there is positive 3/2. Fractions. Negative 3 times 3/2 is negative 9/2 plus 4. Well, negative 9 over 4 plus 4. Sorry, negative 9 over 2 plus 4 really makes negative 9 over 2 plus 8 over 2, which is negative 1 over 2. Then negative 3 times 5/2 is negative 15/2 plus 4 is really plus 8/2, which makes negative 7/2. Okay. First column, done. 1, 0, 0. Second column, negative 1/2 is fine. It stays there. That 3 needs to become a 1. How do I make a 3 into a 1? Divide it by 3. So we divide that second row by 3. Top row doesn't change. It's done. We just carry it along for the ride now. Second row, divide it by 3. So 0, 1, negative 2, 1. Third row, right now it's 0, 3/2, negative 1/2, negative 7/2. I want that 3/2 to be a 0. So I'm going to make it a 0 by multiplying the second row by negative 3/2. Now you might ask, why the second row and not the first row? because if I were to multiply the first row by something and add it to the bottom row, I would lose the 0 that I have at the beginning of that bottom row. So I choose the second row because that 0 I have at the beginning of the second row will add to the 0 I have at the beginning of the bottom row and keep 0 at the beginning of the bottom row where I want it. All right? So we've got in the top row 1, negative 1/2, 3 halves, 5 halves. In the second row, 0, 1, negative 2, 1. In the bottom row, we're going to multiply the second row by negative 3 over 2. So this is negative 3 over 2 times row 2 plus row 3 is going to replace row 3. So negative 3 over 2 times 1 is negative 3 over 2 plus 3 over 2 is 0. That's what we wanted. And then negative 3 over 2 times negative 2 makes positive 3. Add that to negative 1/2. Makes positive 6 over 3 minus 1/2 is positive 5 over, 6 over 2 minus 1/2 is 5 over 2. Negative 3 over 2 times 1 is negative 3 over 2 plus negative 7 over 2 makes negative 10 over 2, which is negative 5. Bottom row. Almost finished. That 5 over 2 needs to become a 1. How do I make 5 over 2 into a 1? Well, I divide it by 5 over 2, which is the same as saying I multiply it by 2 over 5. Multiply by the reciprocal of it. So, top row doesn't change, second row doesn't change, bottom row 0, 0. I divide it by 5 over 2, which means I multiply it by 2 over 5. That gives me a 1. And then negative 5 times 2 over 5 is negative 2. Now I've got my triangle that tells me right there that z equals negative 2. Work my way up. Y minus 2z equals 1. Well, y minus 2 times negative 2 equals 1. Y plus 4 equals 1, so y equals negative 3. Go up to the top. X minus 1/2 times y, where y is negative 3, plus 3 over 2 times z, where z is negative 2, equals 5 over 2. A lot of fractions there. All the more fun. So x plus 3 over 2 minus 3 equals 5 over 2. So x equals 5 over 2 minus 3 over 2 is 2 over 2, which is 1, plus 3 is 4. My solution set is the point for negative 3, negative 2. All done. That is, of course, the point where those three planes, represented by those three equations, intersect, as you remember from earlier in the course. And now, your immediate practice problem. Solve using an augmented matrix, Gaussian elimination, putting it in row echelon form. X minus 2y plus z equals 1, y plus 2z equals 5, x plus y plus 3z equals 8. That is the end of the video on augmented matrices.